Welcome to Computer Metanoia. My name is Anand Sharnal and we are actually talking about the digital electronics. And this is the very first video on the lecture series on digital electronics. So the first topic that I'll be starting off with is called representation of Boolean functions. Now many of you might argue with the fact that I should have started off with the number systems at first, but what I feel personally is that number systems is quite an easy part that is quite easy to understand. So instead of devoting much time into that, I would invest more time on these aspects of the digital electronics which requires a lot of practice and understanding. I will actually do the number systems at the end of this particular video series with say a few videos, 2 3 videos, and that will actually be enough for you to understand the number systems. But the most important part is these understanding these Boolean functions, the simplification of them, the different logic gates that we have, etc., etc. Now let us start off with the topic of representation of Boolean functions. Definitely so. Now, before I start off with this, let me do some justice to the term digital electronics. What does digital electronics mean? Now, in simple words, digital electronics simply means a binary digital system. So we have this written on over here that digital electronics means binary digital system. Now I hope you are being able to see, in fact, if we break down this binary digital system into two segments, we will see that we have the term bi and digit over here. So basically what it means is that, what does bi mean? Bi means two. And what does digit means? It's a numerical value. Fine. So it is actually a system where we use two digits to represent the entire problem. So here you can see that in binary digital system, we use zeros and ones to represent that particular system. Now we all are quite familiar of this fact that we represent the digital system using zeros and ones. Now, the thing is that we have two kinds of system. One is the analog system and another one is the digital system. Now, I can assure you this fact that that the analog system is actually made up of components like diodes, BJTs, that is a bipolar junction transistors, MOS, metal oxide semiconductors, components like this. But interestingly, in digital system as well, these components are itself used. But there is a fundamental difference between an analog system and a digital system. What is the difference between them? In analog system, we use a continuous voltage level, whereas in digital system, we use discrete voltage levels. So if I can make you understand using two graphs, you will see that in analog system, the voltage time graph is continuous. That is, it can attain any number of values, any values, there is no restriction in it, and definitely the voltage will be continuous. There will be no breakpoints in this particular graph. Whereas in digital systems, we actually use two main voltages. One is the high voltage and another one is the low voltage. Now, you can see that this particular graph is broken. You see, from here to here, it is a high voltage region. And after that, it straight away comes down to the low voltage region. And you see that these two lines are not joined. They are just perpendicularly separated to each other. And the value is just a particular value at a high voltage and a particular value at low voltage. No other values in between or above or below those regions are attained by this particular digital system. Um, the voltage time graph of the digital systems. Now, let us come to the fact that in digital system we say two values, right? One is 0 and 1. Now this 0 represents nothing but a low voltage and 1 represents nothing but a high voltage. So this is the basic representation of 0 and 1. We don't represent it as using voltages, right? For example, in most of the cases, if you have done any lab practices of digital electronics, you find out that you consider the high voltage as 5 volt and the low voltage as 0 volt. Now, representing a number using 0 volt and 5 volt in that way, it is quite difficult. So we actually have converted it into zeros and ones, a pattern like that. So it becomes easier for us to understand. and this is it is an universally uh, uh, accepted uh, convention that 0 is used to represent a low voltage and 1 is used to represent a high voltage, considering the fact that in that it is that means in this universe we are the only living beings and there is no other convention in some other planet. Now let us consider let us come to the fact that what do we do in a binary digital system. Now, what we try to do in engineering is that we take up a problem of our real life and we try to represent it or try to solve it using the engineering tools that we have got. The same thing is done using the binary digital system. So what do we do over here? We take up a problem. It may be in any language. It can be in English. The problem, the description of the problem might be in English, might be in Hindi or Tamil or Chinese or whatever it is. It is a real life problem that is given to us, and we then convert it into a binary digital system. That is, we convert it into a language of zeros and ones, which is basically understood by this particular binary digital system. Then we represent it using the simplest form of representation of a binary digital system, that is a truth table. Now a truth table will have two sections. One is the input section, one is the output section. That is, for a particular combination of inputs of zeros and ones, we will get a particular combination of outputs of zero and ones. It may be a multiple input, it may be a single input, it may be a multiple output or a single output, depending on the fact. Now this is the basic outlook of the binary digital system. And in the next video, we are going to understand using an example that how do we represent a particular real life problem and we convert it into a binary digital system, and then we represent it using a truth table, and then how we convert it into an electronic circuit, a digital electronic circuit, which will actually replicate this particular problem in its own way. So that's all from this video. Thank you for bearing with us. Thanks a lot.